with these right triangles, you'll notice that there is one unknown side. We're trying to find what is the length of that unknown side. And so what I'm going to do here is I'm going to use the Pythagorean theorem. So the Pythagorean theorem says that the sum of the squares of the two legs is equal to the square of the hypotenuse. In other words, 15 squared plus 8 squared must be equal to x squared in this particular example. And, well, I can do that by taking 15 times 15 plus 8 times 8. That's 289. So I get x squared must be equal to 289. And if I take the square root of 289, I end up getting 17. So that means this distance, x, would be 17. Now, it's not always going to be the case that you're going to be finding the length of your hypotenuse. You can see in this example, the length of one of the legs is unknown. But you can still use the Pythagorean theorem as long as you take the sum of the squares of the legs. So y is one of the legs, and 13.8 is the other one. So y squared plus 13.8 squared must be equal to 22.3 squared. Now, you have to do a little bit more to get this one working, to be able to solve this one. Let's see, 13.8 squared is 190.44, and 22.3 squared is 497.29. So if we're trying to find y on this one, what I would want to do is, well, I need to solve this equation. I'm going to subtract 190.44 from both sides, giving me y squared equals this number minus 190.44, which is 306.85. And then when I take the square root of that, that will give me y. So I'll just go over here, take the square root of 306.85, which gives me 17.52, we'll call it. I'm just rounding that to the nearest hundredth. There's no guidance here. I'm just giving an approximate. Actually, you know what? I'm going to exercise a little bit more. Instead of calling that 17.52, I'm going to go ahead and call that 17.5, just because both of these are already measured to the nearest tenth of whatever unit we have here. So I'm just going to call that 17.5.